these notes, there are things missing. I'm going to show you what those things are. That way we are all on the same page. It just like didn't print off. I don't know why. So for number 1, there should be an x equals 5. For number 2, there are 2 x's missing. This one and this one. For number 3, I think both x's are missing again by the 4, and with x equals -2. And then I think the last one, you're just missing the variable y. If you prefer x, you can change that, just change it in the equation too. Right, so we are going to start these today. I don't know how much we're going to get done before lunch. But we are going to start these today. And my first question to you is, when you think of the word solution, what comes to mind?
Answer.
Okay. Also, if I'm going too fast, let me know. I can slow down. If you need me to go back to anything, let me know. Also, my handwriting is just trash. If you can't read it, just let me know and I can say what it says. And it's usually worse at the beginning of the year. It gets a little bit better, but like I haven't been writing on smart boards for months. Okay. Anything else come to mind? So yes, the solution is usually your answer. Another way you can think about a solution is what makes your equation true. I'm going to write that up here. Usually when you solve an equation, you get some answer. But in order to make sure that answer is actually your answer, it has to make your equation true. If it doesn't, then it's not your solution. It's a solution, but not for your problem. So, I think I printed this out and I can grab it later. For those that need the completed class notes, ask them if they want them for this period, and I can grab them after lunch.
Okay.
Do you think it will help? In order to determine if something is a solution or not, we have to take whatever they give us or the solution we get, put it back in and see, does it work? Does it make a true statement or not? So for this first one, we're going to take x equals 5. We're going to put it in where x is and see, do we come out with a true statement or not? So we're going to put that 5 where the x was and simplify it. 13 times 5, I want to say is 65, but double check my math. Is that 65? Does 65 minus 7 give us 58? because we got a true statement at the end, this is the solution, or a solution to that problem. Do you have any questions on that one? For the next one, it's almost like a given because we already solved it or found what the solution was. So us finding this negative, we kind of already know it's not going to work, but we're going to try it anyway. We're going to see, is this a solution to this equation? By doing the same thing. Putting negative 5 in for x. And simplifying. Is negative 65 minus 7 going to give me positive 58? No. It's going to be like negative 72. So this is not a solution. It does not work. So when we actually get into more of the solving pieces, this should be something you're doing, checking yourself to see, okay, I got an answer. Is this the right answer? Is this my solution? If I put this back in, do I get a true statement? If I do, then yes, this worked. If I don't, this is not the answer. I did something wrong. Right? Especially if you get one like this, where maybe somewhere you mixed in a negative where it's supposed to be minus or something, and you ended up with negative 5 instead of positive 5, and then you put it back in, well, this doesn't work, so somewhere I messed up. And that would tell you to go back and fix it. Questions on that one? I want you to try the next two, and then we'll come back and talk about them. If you have questions or need help with them, just let one of us know. Let me get your attention back up here. For number 3, did we figure out, was this the solution or was it not? It was not. What was the end result of that?
Negative 1 equals negative 5.
Which is not a true statement. Did anyone get something different? Or does anyone want to see this one work through? For number 4, was this a solution or was it not?
It was not.
Okay, so let's work this one out. So we're going to put negative 34, I'm not going to take that, over 2. Negative 34 divided by 2 is what?
Negative 17.
What is negative 17 plus 5?
That's what I said.
So this was a yes.
And you told me to go.
I did not say that. So yes, that is a big issue. Make sure you have all of your negatives, bringing those down, because if you lose it somewhere, it throws the whole thing off. Questions on those 2 rules?
Not anymore.
I'm glad you found the mistake. The next page talks about properties of equality. So when you're solving, that's what you do to one side, you do to the other. When you add one side, you add to the other, subtract, multiply, divide. Distributive property is a property of equality, but you don't do it to both sides. That's why when we solved the math riddle the other day, and one of them was using the distributed, there we go, property, it works. So these problems are solved for us. We're just looking at from each step, what changed, what happened, what did they do? So step 1 was our given, that was our equation. What changed from step 1 to step 2? What happened, what did they do? Multiply what?
2 times 2x.
So they multiplied that 2 to both the x and the negative 9 using the distributive property. From step 2 to step 3, what did they do? Added what?
Negative.
They added 18 to both sides. And then from step 3 to step 4, division. And what did they divide? They divided both sides by 2. So this just kind of helps you see what they did going from each step. When we get into solving, you could be thinking the same thing. What do I need to do next? Which of these properties am I going to use next? We're going to skip number 2, and I'm going to let you guys do that in a bit, and jump down to number 3. Again, that first example is given. That is our original equation. What did they do from step 1 to step 2? Multiply both sides by 2. So if you're looking at this, I see 1 is a fraction and 1 is not, but the 2 is gone. And I see that this part didn't change, but this did, and the only way I could get 14 from 7 is if I multiplied this by 2. But what I do to one side, I have to do to the other. So what they did is multiply this entire fraction by 2, so that these two 2's would cancel each other out. I'm shortening words. You can write out multiplication property. Also, these are supposed to say property of equality. So I'm just going to start saying POE, property of equality. Same thing. Chicago. I'm sorry, I didn't hear the last one. Okay, you need to go back. Hmm? Let me know when you're good. Right, so we multiply both sides by 2. Now from step 2 to step 3, what did we do? Added 1 on both sides. Added 1 on both sides. And what was the last thing we did?
Divided.
Both sides by 5. Correct. Any questions on how we found those? You guys can go ahead and start example 2. We will come back in 3 minutes and discuss those. If you need any help, make sure you ask one of us. From the first step to the second step, what did they do? Or what did you guys think? They did subtract. So they're using that inverse operation, which we'll get into here in a second, and did the opposite. And then from step 2 to step 3, they multiplied. So it was already a fraction, or they were already dividing, so to get rid of that -3, they would have to multiply. Okay. Any questions on this?
No.
And again, this is just thinking through the process of what is happening in each step. Anyone still need this before I move to the next one? So I'm sure I had an answer for this top one. I don't remember what it was. So this answer is basically the same thing as what we put for solution. To find something that makes the equation true. And in order to solve that equation, sorry, go ahead. We need to use our inverse operations. We were kind of just doing that, but it was already solved for us. Now we're actually going to be solving it, and we have to know what those are. So inverse operations is just that, the opposite. Yep. So what would the inverse of addition be? Subtraction. It's not a trick question, I promise. What would the inverse of division be? Multiplication. The inverse of squaring something. The square root. Cube is going to be something completely different. Yes, multiplied by itself 3 times. And then the opposite of cube is the only one left. So when we actually get into problems that have square and square root, I'll show you why those are inverses if you're not sure why those work. Listed right below are steps, to solve these problems if you're not sure where to start. If you remember how to solve equations, then you don't really need that. Probably. Yes. I think number 1 is supposed to have an X. And number 5 is supposed to have a variable. It doesn't really matter what it is. This one's 2, you can use X, same thing. I think those are the only 2. Okay. We're not going to solve every single one together, but I'm going to show you different ways to solve some of them. Let's start with number 2. Just in case you missed it, well, it's on your page. So if you can distribute first, That doesn't mean you have to distribute first. And we'll get into some examples where that may not be the case. Combine like terms, so if you have two of the same sort of term on the same side, we'll get into other examples when they're not on the same side. You can combine them using whatever operation is in front. And then our goal here is to get the variable by itself and figure out what that is. So with number 2, if I wanted to solve for m, I need to get rid of everything else. I need to get rid of the 4, I need to get rid of the 2, but I can't get rid of the 4 just yet. So I'm going to get rid of the 2 first. How would I do that? And remember, we're doing this to both sides. And how would I get m by itself now? Multiply both sides by 4. These 4s cancel, and you're left with, what is that, 32? Yes. I heard we still get the same answer. I didn't hear the first time. Did you do it a different way? I was going to go over another way to do it. But there are multiple ways to solve these. It's not one size fits all. So we're going to do that first, and then we're going to check to make sure this is our actual answer. Let's say fractions freak you out, you don't like them, you want to get rid of them. Sure, let's do that. So to get rid of that fraction, I would need to multiply that entire side by something that would get rid of this, that would make this a whole number. Really multiply it by a, not a factor, what is that word? Multiple, that's the word I'm looking for. A multiple of this, so 4 would work. I can multiply this entire side by 4, but because I am doing that, I also have to multiply this side by 4. You have to keep it equal. What happens there is this side becomes 40, and I'm going to multiply this 4 to both of these, like I'm distributing. When I multiply that 4 to the m over 4, really the 4s are going to cancel, but if you wanted to see that, I could write it like this. And when you know those 4s are going to cancel, so you would have just m here plus 8. Now you no longer have fractions, and it became simpler to solve. From here, I'm still trying to get m by itself, so I would subtract on both sides. And even though I solved it a different way, I still got the same answer. So yes, to answer your question, you can solve these different ways and still get the same answer. Now sometimes you may solve it an incorrect way and luckily get the same answer. Those aren't the same thing. Before we check this, do we have any questions on how we got either one? So now I'm going back and I'm checking, does my answer work? Will I get a true statement? So I'm going to put 32 back in for m. And see, does that work? 32 divided by 4 is what? Don't check that. Not 4, not 12. 8. I was gonna say you're close. It's somewhere in between that. 8. And 8 plus 2 is 10. That works. It works. I know this is my solution. I don't need to fix anything. So even though that's an extra step, I would recommend doing that every time. Questions on that one? I think 3 was the next one I wanted to do. Mm-hmm. I'm gonna erase this check, that way we can see 3. That didn't work. 3 you can solve very similarly to what we just did. Solve it how you normally would, add 25 to both sides, and then we'll talk about how to get rid of that 2/3. Or you could solve it the second way. If that fraction you don't like it, you could start off by multiplying both sides by a multiple of 2/3 to get rid of it. I'm just going to do one way, but if we want to see that second way, I can do that. So start off by adding both sides, adding 25 to both sides. What was it? I don't think it's a 5. Oh, yes. Okay. I was gonna say it might be 130, but it wasn't a 5. But thank you for checking. When you get rid of these fractions, you can do them separately. Like you could multiply both sides by 3 and then divide both sides by 2, 2 separate steps. Or you could do them all at once. By multiplying this by what is called the reciprocal, you're taking it and you're flipping it. So if you take that fraction and you flip it and multiply that on both sides, these 2 fractions cancel each other out, and you're just left with P. And then you can either multiply 140 times 3 and then divide by 2, or divide by 2 and then multiply by 3. That order doesn't really matter. You'll get the same thing either way. But what would that be? That sounds right. Do you have any questions on how we solve that? Does anyone want to see the second way where you get rid of the fraction first? Okay. I'm going to do that on a separate piece of paper. But it's not in all of the others. 2/3 P minus 1/5. So just like example 2, we could multiply both sides by something that would make us get rid of this fraction. And we're going to use the reciprocal of this. So multiply both sides by 3/2.
It's 3/2 times 2/3. Why does that cancel? What does that do? 3 halves times 2/3 equals what? A big bad 1. That's what you're trying to get to is 1, because anything times 1 is what? Anything times 1 is what?
It's
Whatever the number is, right? Anything times 1 is what?
same or whatever you started with. And if you weren't sure about what that was, you could multiply across. 3 times 2 is 6. 2 times 3 is 6. 6 divided by 6 is
1 times anything. That way you just do this swap with the P all by its lonesome.
So these are going to cancel, become 1 or just P. You're going to multiply 3 over 2 times negative 25. So again, I would multiply and then divide. This one you're going to end up with a decimal because of the number below. 3 times 25 is 75, negative 75. Divided by 2 is 30. I don't feel like I did that math right. What's 75 divided by 2? Someone check that for me.
37.1.
Okay. Sometimes I doubt my math. And then 115 times 3 halves, or 115 times 3, and then divided by 2. What would that be? Multiply by 3 and then divided by 2? Yes. That sounds right. And then add this. Now I did change this to a decimal, but if you left it as a fraction, it would be the same thing. I'm going to say this would still be 210. This one, I don't know if it would be better or worse to try and get rid of the fractions because you didn't start off with a nice fraction. If it was like a fourth or a half, it might be easier. 3s are just ugly fractions to me, in my opinion. Questions on that one? Let's check it, make sure it works. This one. What is 2/3 times 210? Can be a decimal, a repeating decimal, if you are using your calculator. Well, what do we get for that? Ready? Say that one more time. Times 2/3, you got 140? Yeah. I was thinking just dividing it by 3 to get a decimal. But yes, you're right. That does work. That is our solution. What time did we get out? 12:00. Okay. Of the ones left, I definitely want to do 2 more with you and see if you can do the others. With problems like 5, there are a couple different ways you could go about doing it. I'm not going to solve it entirely, just kind of walk through different ways. The one is probably the more obvious one that you would do, distribute both and then start solving it from there. That's not always something you have to do. If the number in front of the parentheses and the number that it's equal to are, like I could divide this and it not give me a fraction, you could, instead of multiplying this number, you could divide both sides by this number and work the problem that way. That's a different way to solve it that would still give you the same answer as long as all of your other math is correct. That's what I was saying. You could do it that way or you could do it this way. Both ways are correct. There's always more than one way to solve these. If you feel more comfortable just multiplying by -3, do that. I'm just saying, if you saw, well, I could divide both sides by -3, I'm just going to work this out. And keep going and keep solving it like that to make it easier. If you see that that's easier, you could do that as well. I'm going to stop right there because you could continue this. I want to do 6. And I'll let you guys choose between 7, 8, and 9. Which of those? We'll do 6 and we'll do 9. As you're working on the other ones, if you get stuck or need help, just let one of us know. Alright. I'm going to rewrite this because I'm going to need space. Someone read that problem off to me. Right? With this one, you can do it so that you're doing it with the fractions, or you can solve it so that you don't have fractions. We'll do both. With the fractions, the only way that I could combine these two fractions is if they have the same denominator. In order to get them to have the same denominator, I need to change these denominators. Think of multiples of 3 and multiples of 2. So numbers that you, like 2 times 2 is 4. 2 times 3 is 6. Those numbers that you multiply to get, where they have the same number, 6. So I would multiply 3 times 2 to get 6. But with fractions, they're very much like equations. What I do to one side, I have to do to the other. So I would also have to multiply this by 2. I can multiply this 2 by 3, but I would also need to multiply this x by 3. So in this way, we're just changing the fractions. We're not changing the entire equation or multiplying something to the entire equation. So it doesn't need to happen on both sides. So this is 2 times 2x is 4x. X times 3 is 3x. Now I have the same common denominator. Now I can combine these fractions. I can rewrite this as 1 with the same denominator. Here I have 2 of the same like terms. These both have x's, so I can combine them by adding them together. And then solving this for x. So I could multiply this by 6. These would cancel, leaving just 7x equals 42. And divide both sides by 7. I could have also multiplied both sides by the reciprocal, 6/7. So if you were to get a problem like that, I would take it step by step. Okay, what do I need to do first? Am I solving it this way? If so, I need to get the fractions to have the same denominator and go from there. Have any questions on how we got that before I show you the second way? The second way, you're like, I don't want to deal with the fractions at all. I want to get rid of them. Then you need to multiply this entire side. I'm sorry, this was supposed to be a 2, not a 3. By something that would make them reduce to a whole number. In this case, it's going to end up being the same thing. I'm going to end up multiplying, or the number's going to be 6, sorry. And I'm going to multiply both sides by 6. So I would look at the common multiple between the two and multiply the entire side by that. And we're going to do this step by step. So I'm just going to multiply this 6 across. We could simplify it all in one. I'm not going to do that, so we don't get lost. So 6 times 2x would give us 12x. 6 times x would give us 6x. And when you're multiplying like this, you can think about 6 is really over 1. So you're just multiplying, to the numerators, not the denominators. I can divide these numbers. So this would give me just 4x. This would give me just 3x. And now I no longer have fractions. I again have like terms that I could combine. And then I could divide to figure out what x is. So that one has less steps, but it's really which one is more comfortable for you. And solve it that way. Do you have any questions on how I solved it the second time? I'm going to put this back in so we can check it, and then we're going to move on to 9, and then I'm going to let you guys do some on your own. Yes, just scan. So putting 6 wherever the x was, I get 12 over 3 plus 6 over 2, which is 3. What's that? It might have been. Okay. 12 divided by 3 is 4. And 4 plus 3 is 7. So that works. The goal is, if you get problems with fractions, not to freak out. Yes. This is still, what is that, 6? Yeah. I was just doing it on a separate piece. Okay, questions on on that one before we do our last one? For number 9, what would you do first? I heard multiplication. Multiply what?
Multiply 5 to the 3m
And make sure that's a negative 5 that you're multiplying.
and 4 minus 15
From there, what would you do?
divide by 3.
Okay. So 4 minus 15 is going to give us
11, negative 11m.
Now this has become much simpler. Add 50 to both sides. Sure, those are supposed to give it to you. And divide. What does m equal?
Negative
Negative 16. We can put this back in, make sure it works.
Oh, that's too much. That's too chaotic. This is what I started doing. I don't know.
One of those didn't work.
Doing mental math. Alright. So if you put that back in, that does work. I just did that for you just because there was a lot of numbers. But that one does work. Of course, if you have your calculator with you, that process is much easier and you don't need to show that. Do we have any questions on solving multi-step equations? And I know that's something we've done before. Do we feel like we remember it a little bit better?
I hope so.
And if you're still stuck on it, don't say, oh, I should have got it the first time. If you didn't get it the first time, you didn't get it the first time. So, let's get it solved now. Fix it. Not as honest with this. Your year is not going to be fun if you don't get this fixed now. Please do it. As I said, good news. Bad news, going to get better with how you feel on this now. Your stuff. Don't say, I'll figure it out later.
Right, right. Alright, so the questions that are left are 1 4, the rest of 5, or you can start 5 over, 7, 8, and 10. Try those problems. I know some of you already started on them, but try those problems for the rest of class. We'll be walking around if you have any questions. You do have a homework that is due by next class on Delta Math. So if you haven't signed up for Delta Math, you need to do that. Next class, we'll go over any questions you have on that. But make sure you join Delta Math. I know some of you have, but most of you have not. These problems are not homework. They are just for practice. So if you feel like you got it and want to just do the Delta Math right now, be my guest.